This is velocity and speed in class examples. We have a non-calculator. Two particles move along the x-axis for 0 to 6. The position of particle p at time t is given by p of t is 2 cosine pi over 4t, while the position of particle r at time t is given by that cubic polynomial. Letter A, for 0 to 6, find all times t during which the particle r is moving to the right. So we're going to take the derivative, which is 3t squared minus 12t plus 9. I'm going to factor out a 3. Factor, so what we've done is really we've set all this equal to 0. So t equals 3, t equals 1, and then we're going from 0 to 6. So if you plug in a half, let's say, you get a positive. Plug in 2, you get a negative. Plug in 4, you get a positive. So the particle is moving to the right on 0 to 1 and 3 to infinity. Letter B, for 0 to 6, find all times t during which the two particles travel in opposite directions. Let's take the derivative of p. Derivative of cosine is negative sine, so that's where we get negative. That's where that negative comes from right there. And then we need to multiply by the derivative of the inside, which is pi over 4. So if you multiply 2 times pi over 4, that's pi over 2. There's the pi over 2. Then this function is going to be 0 when t is 0. Sine of 0 is 0. And sine of pi is 0. So when t is 4, and it'll cancel out that 4, and you get sine of pi. From 0 to 4, p of t is actually negative. You can plug in 2 right here. 2's in there. Then we'd have negative pi over 2 times the sine of pi over 2 if we plug in 2. Sine of pi over 2 is 1, then 1 times negative pi over 2 is negative. So from 0 to 4, negative. And then after 4, we get positive. Like the sine of 5 pi over 4. Sine of 5 pi over 4 is actually negative. Negative times a negative is a positive. And then we already know the values for r prime of t. So from 0 to 1, that's 0 to 1 here, r prime of t is positive, p prime of t is negative. So 0 to 1, they're going opposite directions. Then 1 to 3, they're going the same. But then this little piece right in here, 3 to 4, p prime of t is negative, r prime of t is positive, and then they both become positive. So 0 to 1 and then 3 to 4. C, find the acceleration of particle p at time t equals 3. Is particle p speeding up, slowing down, or doing neither at time t equals 3? And explain your reasoning. So the second derivative of p, here's the first derivative right here. Derivative of sine is cosine. It's already negative. And then times pi over 4. So let's see. Ooh, shouldn't that be pi squared? All these should be squared. Pi squared over 8. Pi squared over 8 squared. Squared. Fortunately, none of that changes the signs. So then we plug in 3. There's p double. Here's p prime. And it turns out p prime is negative when we plug 3 in. Sine of 3 pi over 4 is square root of 2 over 2. That's still negative. If we plug 3 into the second derivative, the cosine of 3 pi over 4 is negative. But then that causes the second derivative to be positive. Since the first derivative is less than 0 and the second derivative is greater than 0, and we could probably say at t equals 3, particle p is slowing down. The first derivative and the second derivative have opposite signs. For letter D, write but do not evaluate an expression for the average distance between the two particles on the interval 1 to 3. Well, the distance between any two things is the absolute value of the first one minus the second one, or you could say the absolute value of the second one minus the first one. So the order of this right here, the order of that doesn't matter. Now, if we want the average value of a function, no matter what it is, it's 1 over b minus a, so it's 1 over 3 minus 1, that's 2, times the integral from 1 to 3 of that function. Well, that is the distance they are apart. And we take the absolute value because it doesn't matter who's on which side. If you're 3 feet apart, you're 3 feet apart. It doesn't matter which side you're on. Here's the rubric. There's the rubric right there. Take a look at that. You can see the point values. Here we need a calculator for this one. I'm going to assume you know how to use a calculator. Two runners A and B run on a straight racetrack for 0 to 10 seconds. The graph above, or off to the right here, which consists of two line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of runner B is given by the function v, defined by this function here. So letter A, find the velocity of runner A and the velocity of runner B at time t equals 2 seconds and indicate units of measurement. So the velocity of A is, I just need this. This is the graph of the velocity. I just need that point right there. Well, the equation of this line segment is y equals 10/3 x with a y-intercept of 0. So down here on letter A, I already have written out runner A, the function's y, was it 3/10? Rise over run. 10/3. 10/3 x, not 3/10. So we have 10/3 times 2 because it's at time equals 2. So you get 20 over 3 meters per second. For runner B, all we have to do is plug 2 in. For each of these, we get 40 over 7 meters per second. B, find the acceleration of runner A and the acceleration of runner B at time t equals 2 seconds and indicate units of measurement. Well, now, if this line is the velocity, then its slope is the acceleration. So the derivative of this little equation that we came up with is 10/3. So the acceleration is simply 10/3 meters per second squared. Now for the other one, for runner B, we just have to take the derivative of that function, which is bottom times derivative of top minus top times derivative of bottom over bottom squared. Or you could do, since we can use our calculator for this, we could have done math number 8 and gotten this value as well. So we did the quotient rule on this, plugged 2 in, you get 72 over 49 meters per second squared. C, find the total distance run by runner A and the total distance run by runner B over the time interval 0 to 10, indicate units of measurement. If this is the graph for velocity, then the area under the curve is going to be the distance, the total distance run. Now, none of this area is negative, so I don't have to worry about taking the absolute value of any of those areas. So the total distance for A is 1/2 3 times 10. That's the area of this triangle, the area of that triangle there. And then we have a rectangle left, that's the 7 by 10. So you end up with 85 meters. And then for the second one, we're definitely going to use our calculator because we're going to take the integral of that from 0 to 10. It ends up being 83.336 meters. Here's the rubric. Notice that they came up with 8 points and then like, well, what are we going to do for the last point? And that 9th point is all the units. Here, to integrate this one, we're going to have to do partial fractions. So we're going to factor the denominator. Let me use a different color. Factor the denominator here. And so this original function is going to be equal to something over x plus 3 plus something over x minus 1. Well, we're going to get common denominator in all this. So we're going to multiply by x minus 1, multiply by the x plus 3 on the top and bottom here. And now that all the denominators are the same, we don't need the denominators. So we just look at the numerators. We make this 0, let x equal 1. So 12 is equal to 4b. So b ends up being 3. Plug in -3, we get -15 plus 7. That's -8. -3 minus 1 is -4. So a ends up being 2. So now this function up here, we're saying is the same as this function. And then we integrate 2 natural log of x plus absolute value of x plus 3 and 3 natural log of absolute value of x minus 1, and then plus c. Well, I can bring that up squared, so I don't need the absolute value anymore. But when we take this to the third power, we still need that absolute value. And then plus becomes multiplication, not plus. Multiplication. That's multiply. The antiderivative of 1 over x is the natural log of the absolute value of x. This is x to the -2, so if we add 1, that's x to the -1, but then times -1, so minus 1 over x. Plug e's in, plug 1's in. Natural log of e is 1. Natural log of 1 is 0, so end up having plus 1. So we end up 2 minus 1 over e.